Hello, welcome to section 2.3, all about transformations for TCNJ's Pre-Calc. So first of all, just a quick review of piecewise functions to make sure we're all on the same page. Remember, piecewise functions are functions that are made up of these multiple different pieces that work together. We talked before about evaluating a piecewise function using the criteria over on the right. Today we're going to talk about playing around with it by the picture. So to find f of 1, this is essentially asking what is the y value when x is 1. So we go to where x is 1 and we find out that the y value is 2. F of negative 1 is saying what's the y value when x is negative 1. So that looks to be 5. 2 pi is a little bit trickier. You might not know exactly where that is, but you know it's 6 and change. So somewhere about there. And we realize that we're lucky because it's all in the same height. They're all 5. So whether you're at 5, you're at 7, or you're at 2 pi, it's all the same spot. This is a different question. This is asking what's the x value that makes y equal 2. So we're switching axis. Now we're at y being 2, and I need to find x. This is not necessarily going to be a function, so I can actually get multiple answers. When x is 1, that's a right answer, but so is x negative 2. So this is actually 1 or negative 2. 8, my maximum height is 6. You have to trust me that nothing cool is going to happen off screen. It's not going to be doing loop-de-loops out here or anything that we can't see. I'm showing you all the good stuff. So it never hits a height of 8, and that's just undefined, or does not exist. The domain of this problem, I don't see any fractions, I don't see any square roots, so it's all real numbers. My range has a maximum value of 6, so it's like my ceiling of my range. And it looks like I go down forever from there. You might say like, well, I have this gap in here between 4 and 5, but this branch here goes down forever. So I'm actually going from all numbers up till 6. You could also just say y is less than or equal to 6. It's the same idea. So here we see a pretty similar function. It's got a polynomial, it's got some squiggle to it. We want to list all the points where f of x is greater than 0. Remember, f of x is kind of code for y. So I want y values above 0. So that's going to happen in this whole window. It's going to happen in this whole window. It's going to happen anywhere out there. So all they want us to do is list the points. We don't even have to go intervals. C is part of that. D is part of that. Where x is less than 0. That's a little bit easier to figure out. It's A and B. F of x is increasing. You're increasing when the graph is heading up to the right. So this is all increasing. This is all increasing. This is all increasing. Those other directions are decreasing. So A is part of that, C is part of that, and D is part of that. Mark where f of x equals 2. I assume this wants us to do it in red. So remember we're looking for when y is 2. So that's going to happen there, 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 and there. So that actually occurs 5 different times. F of 2, they're asking for in yellow, is going to be a little bit of a different plan. If I can switch my color here. That's simply asking what is the y value when x is 2. That's a single point. That's a function. F of x equals 2 is not a function. Relative maximum. A relative maximum is going to be a high point in the graph. This is a relative maximum. This is a relative maximum. It picks up that name relative because it's a maximum compared to its immediate neighbors. It's not the highest point in the graph. We have points over here on the right that are higher than those. But compared to its local neighbors, it's a high point. It's kind of like winning the championship football game in your town. It doesn't mean you're the world champion. It just means compared to your immediate peers, you're the best. Alright, so this is a pretty similar idea. They want to know what h of negative 2 is, so I come 1, 2, and that's here. The hardest part about these problems is to identify whether you have the x and are looking for the y, or you have the y and are looking for the x. This is the x, they want to know the y. So h of negative 2 is 1. H of 0 is just asking what's the y value when x is 0. It appears to be negative 1. H of 2, come 1, 2. And I go up there, and that looks to be at 3. H of 3 that looks to be a little bit higher at 4. And again, assume that I'm not trying to be mean here. The right answer is not going to be 2.998. If it's about 3, it's about 3. I mean, worst case scenario, you might have to know a little bit of fractions, like a half or a quarter. But usually it's pretty obvious as to where it falls. My domain. Notice that this has abrupt stops. That's a closed circle, that's a closed circle. So this does not go on forever. My domain starts at -3 and it ends at 4. So the domain of this problem is going to go from -3 inclusive all the way out to 4 inclusive. Find the value for which h of x equals 3. So I'm looking for x values that make the height of this function equal 3. That happens at -3, that happens at 2, and then that happens again at 4. Any one of those x values will produce 3. Less than or equal to 3 is a little bit trickier. I essentially want to think about any point where the graph is below 3. I could just kind of think about that as a dotted line here. Any of these regions are keepers. This little bump up here is no good. Or equal to, technically I need to include these corners as well. So this first region goes from -3 out to 2. In union with 4. I could say bracket 4, comma 4 bracket, but just 4 by itself is my answer. So a lot of the same. F of x equals 4. Is it a y or is it an x? I'm looking for the x that makes y 1. Be careful here, that's an open circle, so that's actually not included. So is this. So I only ever actually hit 1 this one time. It gets a little bit tricky to decide where that fraction is. I'm going to say 2/3. I'm going to use the squiggly equals because I'm not 100% sure of that fraction. I'm just taking a ballpark guess. Where f of x is increasing. This is going down, this is going up, this is going down. So it's really just from this 1 to 1 window. I'm going to use brackets because my circles are closed for both in the beginning of it and the end of it. Domain are just my choices of x. My problem begins at -2. I've got every x choice from -2 all the way up to 2. Now this is harder because I don't have a picture to work with. Pictures make this so much easier. But we do know a little bit how to draw this picture. If I were to factor this, I get solutions of 0 and 5. Because my leading coefficient is 1, I know my parabola is opening upwards. So I know roughly it's going to look like this. This increasing portion happens from the vertex up to the right. That's all increasing. I know the vertex is halfway in between 0 and 5, or 5 halves. So my function is increasing from 5 halves up to infinity. I don't put the bracket on 5 halves because it's not increasing at the vertex, it's bottoming out at 0. It's not increasing or decreasing, it just hits a 0. Relative minimum, well I already know that. A relative minimum occurs at 5 halves. Now if I want to know the y value of that, I've got to plug it in. So I can take my 5 halves, square it, minus 5 times 5 halves. 25/4 minus 25 halves is going to be -25/4. Range of the function. Isn't it interesting how all these things fit together? The range are my choices of y values, and that's my lowest y value. So my range is going to be from there up through infinity. All right, so here we get a word problem. Looks a lot like something you might see in your textbook, perhaps. So we want to determine the intervals. W is increasing. So it's increasing this whole time. Up, 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 up. Even increasing there. And that's where it stops. So maybe around like 28-ish. And then it drops down for a little bit, bottoming out, let's say like 33. And then 33 on, it's increasing. So what do you think happened when this person was 30 years old? Well, something drastic happened, because that's the only time that we've got this decrease here. Now, maybe that happened because they were dieting. Maybe that happened that they had bypass surgery and it made a big change. But something occurred drastically to make a large amount of weight loss. Whether intentional or unintentional, this person lost a lot of weight suddenly over the span of a year or two. I'm going to assume they were dieting. Okay, so now let's talk about shifts. Remember that everything that happens inside the parenthesis is going to be a sideways movement. So this x minus 2 on the inside is going to behave just like a parabola. That's going to cause a shift to right. Now you could just kind of imagine drawing this over 2 to the right, or you can actually use several key points of the graph and decide where they go. This first key point should have been over 2, so you see I missed a little bit. This key point would have been over 2, so that looks like a success. And this point would have been over 2. By controlling those 3 points, you get a very good idea of where it goes. Minus out front is not affecting x, so it's affecting the y. Negatives cause flips. So this is going to be a flip down. So basically it's going to take the entire image, instead of it coming up and over, it's going to now go down and out. Still centered at the same point, except instead of this hitting at positive 3, it's going to hit down here at negative 3, and then it's going to come down. 3 minus is a 2-prong attack. This 3 is going to cause it to go up 3. This minus is going to cause a flip. So again, that's up 3, and then it's going to flip down. You do it in the order that you would evaluate the function. So technically speaking, if I were to plug a number in for x, I'd apply the negative first, so it's going to flip upside down and then lift up 3. This makes a difference because if you go up 3 and then flip, it's a different result. So do think about the order as if you were trying to evaluate the function. If I told you, tell me what y equals when x is 7, you plug it in for f of x, you then flip it, and then apply the up 3. This one, you'd cut it in half, which is going to cause it to be half as tall. Right now this point's at 3, it would go down to 1.5. This point is going to be at 4, it's going to go down to 2. They're all half as tall. After you make them half as tall, you then drop it 1 square. And it's going to cause it down 1. F inverse, we'll get there later. F negative x, this is on the inside, so it's a sideways thing. This is also a flip, but it's a flip sideways. So instead of the graph starting over here and going up, my graph is going to start out here, whatever that distance is, 1, 2, 3, 4. So I'd start off 4, curve into this point, and then go flat out that way. All right, so that's 2.3. Hopefully it made a little bit of sense. I'm happy to talk to you in the next class. Have a good one.